Hey everyone, and welcome to another lesson in Swift fundamentals. Okay, now in the previous series we covered most of the topic in Swift fundamentals. Now we're gonna jump into the data collection book, and we are covering few of the chapters in developed in Swift data collection. Today we're gonna cover protocols. Protocols are important topic that is used quite a bit in Swift, and we will jump right in. All right, so what are protocols? A protocol is a set of rules, procedure that define how things are done. Basically, something that you agree on. Computers communicate with each other using protocols. The most common protocols that we use a lot is HTTP, which is hypertext protocol, and TCP/IP for communication, transmission control protocol. And HTTP is the standard used on, it's the standard that defines how websites communicate. So what is it? It's a blueprint of methods, properties, and other requirements that suits a particular task or a piece of functionality. So you can enforce this functionality. So say, okay, if something adheres to this protocol, I want to make sure that they implement the following functions, all right? We will cover 3 protocols. These are in the standard library, and these are equatable, comparable, and codable. Okay, and codable is missing here. All right, we'll talk about it in a minute. But when you adapt to a particular protocol, you must implement all the required methods that are defined in the protocol. So let's get started. Let's dive in. We have 2 structures in this case. One structure is an employee, another structure is a company, and then we've covered structures previously in the Swift fundamental. This employee has the following attributes: first name, last name, job title, and phone number. Now we're going to talk about equatable. Why do you use equatable? Well, let's say you have a list of employees, and then you want to compare if an employee is equal to a particular employee. For example, if you have an employee that is logged in and that is set in the current session, you want to compare, and you create another employee or selected employee. And in this case, we create an employee with the following attributes: Jacob Edward with the last name, job title, and the phone number. Then if you want to compare this current employee with the selected employee, and you say, okay, how I'm going to compare them? What do I compare? Right? Because these are just objects. What do I compare from these objects? Well, if you make this structure employee adhere to the equatable protocol or implement the equatable protocol, then you have the freedom to implement the method that you want to compare these employees. So if you go to the next one, here is an example. If you make this employee adhere to the protocol equatable or implement equatable, that means that you need to implement the methods that are required by this protocol. So in this case, you implement a method called function. You implement a method func equal. And this method receives 2 parameters, the left-hand side and the right-hand side, and a return Boolean. The left-hand side is a type of employee, and the right-hand side is a type of employee. What you just done, you've created a powerful way to compare any 2 employees that conform to this structure and implement equatable. This function is a static, and static, if you don't know what static is that it's basically a function that you can call without having to create an instant. Now, what can you do in here? Well, you have the freedom to compare any of those attributes, or you have your own logic to make that comparison. So if we look at the next slide, we're comparing the left-hand side employee, first name, the right-hand side employee first name, if they are equal and their last name are equal, then we will return the result of this. The result of this is going to be true if all these conditions are true, because we're using AND. So now you can see you're saying two employees are equal if their first names matches and their last name matches. If we look how we implement this, so if we create two employees here, current employee, and here's the attributes for the first employee, the selected employee here, the attribute for the second selected attributes, and these are the attributes for the second employee, the selected employee, and you notice first name Jacob, last name Edwards. So when you're checking this, if current employee equal selected employee, what will happen? You will call this method, and then it compares if these two employees are equal or not based on these criteria, based on the criteria you specified here. So if they are equal, this condition is true, and you will return true. So this condition in this case will be true, and then you can enable editing because the same employee, the current employee is the same as the selected employee. Now you can go farther than this by implementing a more robust condition. And then you're saying, okay, maybe two employees have similar first and last name, and that could happen. And then I want to say, okay, I want to make sure also their job title is the same and their phone number is the same. So now the chances that these two employees are not the same is almost nil, because you're using 4 values to compare them if they are equal or not. So that is equatable. What do you use it for? You use it for comparing two complex data types, in this case, employees, trucks, and then you have the freedom to implement whatever function, the equal function, and then you have whatever criteria you want when you compare those two values, two objects. The next topic we're going to cover is comparable. Comparable is used mainly to compare objects not equal. The other one, check if they are equal. Here you can check if they are less than, for example. You say which one is less than the other. So you're comparing two objects here. The prime example for that, if we have a list of employees, and then you create an array of these employees, and then you want to sort these employees based on their last name. Well, you could build your own algorithm or methods to do that, or you can let Swift help you and use the sorted function in the array. So how do we do that? First, we need to make sure that employee structure also implements comparable protocol. So in addition to equatable, you can have a list, or you can have more protocols when you separate them by comma. So now we have equatable, and we implemented the method for equatable. Now we have comparable, and then we're going to we need to implement the method for comparable. And it works the same way. So we'll still have a static function. And then here the function is the less than. You still get left-hand side and right-hand side parameters, and then you still return a Boolean. So this one get called when you're comparing if one less than the other. So what kind of criteria you're using? You're using the last name. If the last name of the left-hand side employee is less than the right-hand side employee last name. So this will return true. Where can you use that? We can use it in the next example. This is my array of employees. I'm creating a new sorted employees. And this new sorted employees is based on the old employees. And I'm going to sort it using the function sorted. And I'm going to sort it by the less than. So now for every, it will actually call this function when it makes all that comparison. And it's sorted out for you. You don't have to do anything. You don't have to create your own algorithm or anything like that. So now it's all done by simply making sure that struct is actually conform to the protocol, compatible, and implementing the method that is needed, which is the less than. And after this, if you print out the data for employees in the sorted employees, you will actually get sorted employees. And if you look at their last name, is alphabetized by starting with A's and by ascending orders. Okay. So these two are very, very powerful, comparable and equatable. With simple implementation, you can sort your data the way you want it. You can have your own custom sort if you want, not only based on the last name. You can have any field in this, and then you can sort it based on that. All right. The next topic that we're going to cover. Oh, and by the way, you could do the same thing by implementing these two methods, the less than and then the equal. You can actually cover all the other combination. You can cover the not equal, the greater than, the less than or equal, or greater than or equal. So here is the result for the greater than. Because we implemented the less than and the equal, automatically you will get these as well. So if you just simply, I want to sort it by ascending order or greater than, it's actually the other way around, descending order. It means that you'll see the last name is Phillips, and so forth. So this will be in descending order. Very powerful. The next topic I want to talk about is Codable. And this is the right spelling for Codable. In many situations, what happens, what you end up doing is that you wanted to sort some data. You create some data, and then you want to be able to save it in some sort, in a file, or being able to read it from the internet and being able to view it in a plain text. So Codable allow you to save your data in a key value pairs. And then you can take these objects from memory, and then you can encode them to form a data that can be written to a file. And the same can happen if you can get data. For example, you get data from the internet, like in a JSON format, which we're going to talk about, and then you can convert them into objects as well. So Codable allow you to decode and encode data, all right? And this is quite important to us because that's what we're going to use in the next lectures when we talk about calling web APIs. So how do you do it? Now we have this employee actually conform to 3 protocols: equatable, comparable, and then Codable. These stays the same. With Codable, you really don't have to do anything. You don't have to implement any functions here with Codable. You want to make sure these attributes, the name of these attributes matches the names of the, if you're getting data from the net, from this JSON data, I want to make sure that they matches the JSON data attributes. And we'll talk about this in the next lecture. But how do you take a bunch of objects or an object and encode it into JSON data? If you look at this example, we have an employee. It has a first name, last name, and job title, same information that we had before. And then I create a JSON encoder. This JSON encoder object we can use to decode or encode this object into JSON data. So we will spend more time in the next lessons when we talk about this. So you say JSON data, try JSON encoder, the encoder that we created here, and it will encode bin. Because we're using JSON encoder, there's a special topic about JSON that we will cover later on. Then what it means that this JSON encoder will take this object, the attributes become, these attributes, field names, if you want to call them variables, in the structure become attributes in this JSON object. And then these values becomes their value. So key value pairs. So we'll create all these key value pairs for you. And if you print it, because I wanted to be able to print it, so I convert this JSON data into a string with Unicode encoding, and then I just simply printing. So here you'll see that this is a JSON object. It has a curly bracket at the beginning, curly bracket at the end. And here are my attributes: first name, last name, job title, phone number. Those are my keys. And the values are the one next to each attribute. So this will be bin and so forth. Now, the beauty about this, you can take this JSON object now and send it over the net, or copy it to a file, or put it in an email, whatever you want. But it encode this JSON encoder encoded the object for you. And the reason you're able to do that is because of this Codable protocol. That's it for today. And we're going to do in the next lecture, I'll show you how we access the web. And after that, I'll show you how we use the Codable protocol with the data that we receive from the web and parse out the data and display it on the screen. I'll see you in the next video.